Hey everyone, welcome back to my YouTube channel. If you're seeing me for the first time, this is Santosh. Today we are in another video of a Kafka tutorial. To be honest, this is not the first video in this course. We already gone through what is the complete agenda for this entire video series. And also we already gone through introduction of the Kafka, like what problem it is solving and something like that. And today's video, we are going to more focus on the Kafka terminology. The first thing is if you like this video, please don't forget to subscribe. And to be honest, in my videos, I will more focus on the theoretical part because we are in 2025. So installation of any particular software or some platform, it's matter of executing few commands, but it is very important to understand the theoretical part of the technology. Meaning, let's say if you're learning something on the Kafka, it is very important to understand how Kafka works and what is the problem solving by the Kafka and where we can fit this Kafka technology into day-to-day life. That is something like that. So with that said, let's go ahead and cover more on the Kafka terminology. In this terminology, we are not just going to talk about what is topics, partition producers, and all these terms. But what we are going to do here is we will pick the one real life example. Maybe we can pick one social media, and let's try to understand how it works in very big picture. And then after we can try combining how Kafka is going to help in those scenarios. So while we are talking about that particular entire architecture, during the time we can reveal the terminology of the Kafka, like what is topic, what is partition, what is consumer, publisher, and all those things we will cover in the that real life example. So with that said, let's go to our whiteboard, and here we can try understand all those terminologies. So as I just described, let's understand we have some social media platform. Maybe let's consider X, Y platform. So before we really go into the architecture of this platform, let's understand what are the capabilities, right? So let's assume that using this platform, we can share the pictures, like we can post the pictures, and we can give something like a description for this picture, and you can also have some sort of hashtags. And anyway, hashtags will come under the description itself, and maybe you can also write some subject. Let's assume this is one capability, and the second capability is we may have some feature like let's say you posted some picture so that your friends can like that picture, or maybe if your friends are posting some picture, so you will have the capability of liking that picture. So this is second capability, and the third capability is maybe we can enable something like comments. So whenever you see some picture, you can write down some comments for that picture, and then you can post it. So let's assume that these are the key features in this particular platform. So now to do all these actions like posting some images into the platform, or liking particular image, or commenting to the particular post or image, we must send these details to the backend platform, right? So let's understand that this is our mobile application, and within the mobile application, we have all these features. So whenever you click on few buttons in the mobile app, that information will come to the backend platform. So let's assume that this is the backend platform, and this platform is going to be the Kafka. So just bear with me for a few more minutes. We are going to reveal the terms one by one. But let's assume that this particular big box right here, this is the Kafka platform. So whenever you post some message, message means like here. Let's go to the terminology. So whenever you are posting some message in the Kafka, we call that as event. So how this event is going to look like? So for example, this can be any message, but just to make it to the real life scenario, so this can be some sort of a JSON data. So here, what we are going to have, the very first one is like what is image path, meaning let's say you are posting some picture, right? So whenever you're posting something, that image can be uploaded to the some cloud platform, or maybe this is going to sit in some S3 bucket, right? So that image will go to the S3 bucket, and here it is going to construct one image path for us. So let's assume that this is image path and posted by, and this must be your username, right? Whatever the username you have for your account, that should be here, and the date, time, and of course a description. So let's assume that this is the very simple message which is constructing by this mobile app whenever you are trying to post the some image. So right now we have this particular message right here, right? So in the Kafka terminology, we call this as event. So event is nothing but it is going to contain some information. So that's what it is. So when it comes to the like, it should be very similar. So again, this is also another event. However, here we are going to have little different fields. So what is the image, or maybe this can be the post, whatever it is. And again, here we are going to have that path, whatever the path we are going to have that particular image, and then liked by, right? And this should be again another username. This may be your friend's username. If your friend is liking it, then it must be your friend's username. Or if you are liking that particular post, then it must be your username. And again, date time. So let's assume that these are the fields for the like event. Similarly, for the comments, this is also another event. And within this JSON data, here we are going to have image path, very similar to the like. And what is the comment, right? We need to have that comment, right? Like this picture is awesome, maybe something like that. So this could be something like pics are great and commented by, and this must be the username, whoever making that comment, that's the username, and again, date time. This is some timestamp. So if you see here, we have three events. And what is the similarity? So here, let's say hundreds of users are posting some pictures. So the common scenario here is whoever posting it, the syntax or the schema, it's a pretty much same, right? So let's say if 100 guys are posting here every single time, the schema is same because image path that's the same. However, the value that should be whatever the image location that will come to this particular one, and then whoever posted it. Let's say if 100 users are posting for every single event, the username whoever posting it that should be unique, and datetime, that a datetime is going to prepare by the mobile application, like a real-time timestamp will be there, and the description. So whoever making that post, whatever the description they wrote, the description will come here. So if you think through, for all these events, the syntax is very same. And when it comes to the likes right here, so the syntax is pretty much same here too, because whenever somebody is liking, the data is coming into this particular backend platform in this particular format, like what is the image path, and who liked it, and what is the date time. And when it comes to the comments, again, it is going to have the dedicated syntax or schema. And here we have the image path, like whatever the image path we have in the S3 bucket or wherever it is. And then whatever the comment, let's say if one guy is posting like a pics are great, and that should be the comment. If second guy is posting like a pics are awesome, then that should be the comment here. And then commented by, let's say user one is posting that comment, then username will be there. User one name will be there. And then let's say user two is posting, and user two's username will be here, and then whatever the date time, that should be here. So if you think through, the syntax is pretty much same. But when you compare this particular event with this event, the schema or syntax is a little different. So here, what I'm trying to conclude is this particular syntax is very common for n number of comments, and this particular syntax, this is common for n number of events, and this particular syntax, this is going to be common for n number of posts. So in Kafka terminology, we are going to combine all the similar events into one particular thing. That's what we are going to call as topic. So here, since we have three categories, one is event, one is likes, another one is comment. In the Kafka, we are going to create three topics. The very first topic is post. The second one, likes. The third one, that should be comments. So I hope we are very clear now. So in the topic is nothing but it's going to have the events. It is going to have the multiple events which are similar in the syntax. So if I explain clearly, now we have the three topics. One is post, the second one is likes, and the third one is comments. Now, where are these going to store, right? So here we have the Kafka, and this Kafka is nothing but it's going to be, this is one platform which is going to run on top of the servers, right? So here, let's assume that we have three servers. On top of that, we are running the Kafka. Let's assume that. And I will tell you why I picked the three servers here, because I would like to explain that there is another term. But for the simplicity, I just want to pick three servers as my Kafka systems. And so let's assume that each of these boxes are representing the Kafka servers. So in the Kafka terminology, we are calling these as brokers. This is broker, and this is also broker. This is also broker. So if somebody is asking you what is this particular box, or how many, what is the name for the each and every Kafka server, so that should be the broker. So Kafka broker and Kafka broker. And now let's understand the sequence of these Kafka broker. So the Kafka broker sequence will start with a 0. It always starts with a 0, and this should be the 1, and this should be the 2. So if somebody is asking what is this particular box, then that's a Kafka broker 0. And this the second one, this is Kafka broker 1. And this one, this is Kafka broker 2. This is the unique identifier which is going to assign to this particular server within the Kafka environment. Now we understand this Kafka system has a 3 servers. So whenever we have multiple servers in the Kafka platform, we call that as a distributed environment. Distributed environment. And here, this particular whole system, we call this as a distributed events streaming platform. So if somebody is asking what is Kafka, the textbook definition is it's a distributed event streaming platform, but you know what are the events, right? So all these messages coming from this mobile application, these are the events, and these events are eventually will come to the all these Kafka brokers. Now, okay, so if we step back, here we have three different syntaxes, right? So for the events, we call this as the post topic, and for the likes, we call this as a likes topic, and for the comments, we consider this as a comments topic, right? So all these topics are going to be sitting on all these Kafka brokers. Let's assume that this is post topic, and this is likes topic, and this is comments topic. So now what are the generators of all these messages, right? So this particular mobile application is generating all the data for us. But if you deeply think through, within the mobile application, there are several features, right? So when you go to the some XY social media platform, you will have some option to post the image, right? So whenever you add some image and when you write some description, once you click on the post, in the back end, there is some process which is going to send that information. So in this particular scenario, we have three processes. One is this posting pictures process. The second one is a liking pictures process. The third one is the comments process, right? So all these processes are called as producers. So all these are producers because these producers are generating the data. Basically, it's nothing but the producers are going to generate the data. So where we are going to push all this data, let's say this producer, the event producer is generated some data, and where we have to publish the data, right? So that data will come to this particular post topic. Similarly, the likes data will come to likes topic, and comments data will come to the comments topic. How we are going to store this data within these topics, right? So that data, we are going to split it into the multiple partition. Partition is nothing but it's a logical separation of the topics. Let's say, for this post, let's assume that we have three partition. That means for this topic, we are going to have three partitions. Let's assume that this is partition 1. And the greatest advantage of having the distributed environment is this is partition 2. And let's assume that this is partition 1. And let's assume this is partition. So let's say if we have three partitions for the post topic, one partition will be sitting on one server, the second one will be sitting on second server, third one should be sitting on the third server. And here, it's not necessary to have all the partitions in the sequence. Let's say if I have 10 Kafka servers, that partition can be sitting on any server within the environment. So partition 0 can be sitting on the server 1, but a partition 2 can be going to the 5th server, and partition 3, which is P2, can be sitting on the 10th server. So order doesn't matter. The Kafka is going to take care of where that partition is sitting, and it will take care of sending the messages. So now we understand that for the post topic, we have the three partitions, and the partitions are like a P0, P1, and P2, right? So for every partition, we are going to have the leader. Always one partition should be the leader. And the second one, a third one, let's say if we have 3 partitions, the remaining partitions are like a followers. And this is also followers. So in this particular scenario, P0 is the leader partition, P1 and P2 are the follower partition. And now let's understand how these messages are going to sit in the partition. So let's say if user 1 is posting the messages, let's assume this is the partition being. And let's say one user is posting some message and we know what is the syntax for the event, right? So this event is nothing but a message. And this particular event will come to one of the partition. So let's say that partition is that this particular message is coming to here, and this should be message 0. And the second message can go to P1. This is M1. And the third message, it can go to M2. And again, M4, M5, M6, something like that. So basically what I'm trying to say here is whenever the data is generating by the users, the data will come to the Kafka environment in the form of events. Event is nothing but it's a simple JSON data, and this JSON data will come to the partitions, and within the partitions we will have the queue, and within this queue the messages will be sitting one after another one. So this is not like a sequential. Let's say here we have M0, right? So again, if this particular partition is taking the traffic right after M6, let's say here M7 can be here, and again M8 can also be coming here. So whatever the partition is taking the traffic, based on that, the partition is going to add that message into the queue. How we are going to read all these messages? So if you are familiar with the programming languages, let's say Python. Let's assume that this is a Python _1 and this is the list. And if you know what is list, 1, 2, 3, 4, 5, 6. Let's assume that these are the elements we have in the Python list. How we are going to read all these messages, right? So we are going to read all these messages with the indexing number, right? Index is nothing but to read the elements within the list. So how we are going to determine what is the index value for all these elements? In the Python, it will start with a 0, 1, 2, 3, 4, 5. So what is the value of index 5? So that should be the 6. What is the value of index number 3? That should be 4. Similarly, in the Kafka, we call this as offset value. Offset value is nothing but indexing number, and this number will start with a 0, 1, 2, 3, and again this is another partition, so the number will start with a 0, 1, 2, 3, and this is also another partition. The number will be like a 0, 1, 2, 3. So if I ask you what is the value of this particular M8, where exactly it is sitting, right? So now we have to reference starting from the post, which is the topic. So this M8 message will be sitting in the post topic, and the partition should be P0, which is the leader partition. And within the P0 partition, what is the offset value? The offset value is 3. So that's where we have the M8 value. So let's say if somebody is asking where exactly we have the M5 value, again, we have to refer starting from the partition. So that should be post topic and the P1 partition. Within the P1 partition, what is the offset value? Offset value is 1. And let's say if somebody is asking what is where exactly we have the M6 message. Again, we have to start from the topic, which is post topic, and P2 partition, and then what is the offset value? That should be 1. So that's how we are going to refer with the offset values. So now we understand what are the partitions, what are the topics, and we also understand what is the producers, right? So now whenever somebody posted one message, we have to publish that particular message into the platform, right? So for that, let's assume that we have some services on the other side. I hope you guys are following the context. So please bear with me. Once you are comfortable with the terminology and the overall concept, it's a very easy to understand the very high level architecture, and also it's a very easy to deploy some lab environment, and it's a very easy to experiment with it. So here, let's assume that users are posting some pictures, and those events are coming to these particular topics. And to process all these events, we must have some sort of process on other side, right? So let's assume that this is some process which is a news feed. And what is the whole purpose of this news feed? This news feed is going to read all the messages from the topic. So how exactly it is going to read the messages, right? So this news feed will know what is the topic name and then where exactly it has to read the data. So here for the partition for the post topic, we have the 3 partitions. So that here the max number of workers what I can have on the news feed is up to 3 workers. So let's assume that I have 3 workers here. 3 worker means like 3 processes, and each process is going to read one particular partition. So whenever messages are coming into the P0, partition 0, or partition 1, partition 2, their respective processes or workers are going to read messages like what is M0? It will this newsfeed service is going to read M0, and then it will publish into the newsfeed. And the another process is like the worker 1 is going to read the P1 partition, and it will process the M1, M2, M3, and M4. And the another process here, which is a third worker, is going to read messages from P2, and it is going to read messages like M2, M6, and let's assume M8 and M10. So it is going to read all these messages and then it publish it. So in the Kafka terminology, this particular process, whatever we have here, this one we call as a consumer. Consumer is nothing but it is going to read the messages from the topics. So this particular consumer, what is the name for this consumer? Which is a newsfeed, right? So this newsfeed consumer is going to read the messages from the topics. And here we spoke about the 3 workers, right? So all these workers are going to work as a group. So entirely, this is we are going to call as a consumer group. And how many workers we have in this consumer group? We have 3 workers. And how we are going to decide this number? This number always less than or equals to the number of partitions, because if I have 3 partitions here, there is no point of having the 6 workers, because 3 workers are already reading messages from each and every partition. And if I try to read the messages again using some other workers, and that may cause the duplicates of the events. So in the Kafka environment, that is not going to be allowed. That's why we have to stick to the number of workers, and that logic should be like let's say if I have 3 partitions here, the workers within the consumer group, they must be either equal or less than the number of partitions. So now we understand newsfeed is going to read all the post, and then it is going to publish all the post into the newsfeed. And let's assume that we have a second consumer, which is analytics. And this analytics consumer is going to read all the events within the Kafka environment. I mean, sorry, it's going to read all the messages from the likes topic. So let's assume that the whole purpose of this analytics consumer is reading all the messages, all the events, whatever the name is. It could be either event or messages. So the whole purpose of this analytics is reading every single message within this likes topic, and then this is going to do some analytics like how many likes are there for that particular post. Let's say this is the post, and if I have some likes button here, comments button here, maybe share button here, here we are going to see something like 100 likes, and comments maybe 20 comments, shares 1k shares, something like that, right? So these type of details we in the social media, and the whole purpose of this analytics consumer is it is going to prepare these metrics for us, so that whenever you open that mobile app, once you open that post, you can see all these numbers. So now we understand what is the whole purpose of this analytics, right? So analytics is nothing but a consumer which is going to read all the messages in this particular likes topic, and it is going to prepare all the analytics for us. And let's assume that we have another consumer that should be notifications. Let's assume that this particular box is notifications. So this notifications is also going to read the same message from the likes topic, or maybe it can also read the messages from the comments topic. And whenever some like happen, meaning let's say if you like the your friend's picture, and the responsibility of this notification process is notifying your friend by saying you like the picture. Or if somebody commented on your post, this notification process is going to read that message from this particular comments topic, and it is going to send some notification to your friend or you by saying like somebody commented on your post. So that's the whole purpose of this notification. So if you see in the very big picture, now if you see in the very big picture, so here we have the Kafka environment, which is going to contain multiple Kafka brokers. And within the Kafka brokers, we have the Kafka topics, right? And these Kafka topics are going to split into the multiple partitions. And the data, whoever producing the data, so those we are going to call as producers. And whoever the process reading the data and processing it, those we are calling as the consumers. I hope you are very clear on this subject. And now let's go back to our GitHub and let's understand if we miss anything. So I believe we spoke about all these topics, partition, producers, consumers, and brokers. And now the ZooKeeper consumer group offset. I think we spoke about consumer group and offset already, and retention, compliance policies, and ZooKeeper and draft. So just to make our life very, very easy, I'm not going to talk about what is ZooKeeper in this particular session because we are going to talk about Kafka installation architectures and all that in the in the further videos in this course. So during that time, I will talk about what is a ZooKeeper. For now, let's focus on what is the retention policy, right? So here, we are getting all these messages into all these topics. But how long we are going to retain all these messages, right? Because the whole purpose of the Kafka is only the streaming thing. Because here this is not the database, right? So we will just feed all these messages into all these topics, and some process is going to read that message, and then it is going to do all the analytics or whatever it is, right? So this process is going to take care of updating somewhere in the backend database. So the whole purpose of the Kafka platform is giving the high availability, and we already spoke about what is the top advantage of having the Kafka platform, right? So the whole purpose of the Kafka is giving the high availability and providing the streaming platform. So here, let's say if I have 1 million posts into this particular topic, and let's say 2 million likes I have in the topic, and 1 million comments in the comments topic, and it's going to be overwhelm the Kafka platform as well. So what we are going to do here is we are going to enable the retention policy, meaning the older messages which are already processed by the consumer group, there is no point of holding all those messages or events in the Kafka platform. So based on the speed of all the consumer groups, we are going to decide what is the retention policy. Let's say my consumers are almost reading everything in the real time, like maybe within the 10 minutes or 15 minutes, if all the consumer groups, whatever I designed for this particular Kafka platform, if they are able to finish all the messages, then there is no point of holding all these messages more than a day. So here, let's say if I define something like a 24 hours as retention policy, what that means is whatever the messages are older than 24 hours, those are going to be deleted automatically. So that's the another greatest advantage of the Kafka. So we can easily define what is the retention policy based on the topic. So here, let's say for the post, if my news feed is going to read everything in the real time, then we can define like a 24 hours as my retention policy. And here for the likes and comments, if my analytics process and notification process are running very, very slow, which is not the ideal case, but they will also work as the real time. But for the example scenario, let's understand that analytics process and notification process are going to run very, very slow. Here we can define like a 48 hours as the retention policy. So for every topic, we can define like what is the retention policy. So here, if I define 48 hours as the retention policy, whatever the likes messages or likes events came to the likes topic, those are going to be deleted by the Kafka platform automatically. So that's what it is. I hope you understand the whole concept of a Kafka platform. And let's go back to our this video course. Okay, so I think we pretty much covered all the topics for this video, whatever we thought of discussing. And in the next video, we are going to talk about a Kafka architecture. In this Kafka architecture, we can talk about what is ZooKeeper and what are the different high availability. And also we are going to see a little bit on the Apache Kafka, and we will talk about what is Confluent Kafka and all that. I know so far we haven't talked about what is Apache, but we will go through all those. And during this Kafka architecture, we are going to talk about a few things like, let's say if producers are producing the data and how that acknowledgement will work, and some examples and something like that. I hope this video is provided some value to you. And if you like this video, please don't forget to like. And if you have any questions, feel free to mention in the comment section. Thank you so much, and see you in the next video. Thank you. Bye.